Hello, Chem 30. So today we're moving on to balancing redox equations in acidic conditions. So this is just letting us know that so far we have looked at redox reactions where we are predicting the redox reaction, listing everything that's present and identifying your strongest OA and strongest RA. What we're going to take a look at today is balancing in acidic conditions where you might have a reaction present, but it's not showing you everything. So this first part is asking you to identify the oxidizing agent and the reducing agent. Now we can look and take a peek at and see what's happening to Ag. So we have our silver solid and it's turning into silver positive, the ion. So if that's happening, there's a loss of electrons, so I'll say oil, and I would know silver is my reducing agent. It's harder to tell what's going on with MnO4 negative, but we have a way to still balance this out. So we'll just move on from here. So when we are balancing in acidic conditions, this is what we do first. You write unbalanced half reactions and you would relate the reactant to its product. And then step 2, you balance any atom other than oxygen and hydrogen first. And then lastly, you balance out oxygen by adding water molecules. I'm not sure why I said lastly, there's more to this. Step 4, you balance any hydrogen atoms by adding hydrogen ions. And then lastly, you balance the charges by adding electrons. So when we're taking a look at this reaction, so again, we want to see what's related. This is our unbalanced equation. And we can see that the MnO4 here would be related to the Mn2 positive, just like the Ag would be related to the Ag positive. So if I was to look at my total ionic equation, I could split some things up and have an idea. And when you're looking at oxidizing or reduced, we can ignore the oxygens for now, or the fact that there are none, and we will keep going. So we have our two half reactions. So we talked about what's oxidation. So reduction has to be the other one. And the first step is to balance anything other than oxygen and hydrogen. But there is one Ag on the left, one on the right, so that one's balanced. And then for Mn, the ion, we have one on the left and one on the right. So those are already balanced, so we can move on to the next step. Balance atoms, that's what we just did. We can balance oxygen by adding in water molecules. So this first half reaction has no oxygen, so we don't need to add in water. This second half reaction has four oxygen. So to balance that out, we need a 4 and you add in water. So now if we distributed that 4, we would see we have 8 hydrogen that we've introduced, and the 4 going to the oxygen means 4 oxygen. So that leads us to our next step, balance out hydrogen atoms by adding hydrogen ions. So now because you added the water molecule, because of the MnO4, we added water to the right-hand side. So we have the same amount of oxygen on each side. And then as mentioned, this 4 also means 4 hydrogen molecules. So we have to balance that out by adding in, 4 times 2 is 8. So we have to balance that out by adding in that 8 hydrogen on the left. So now oxygen's balanced, hydrogen's balanced, and we move to balance charges. So now both of the reactions we can balance out charges. So for silver, having no charge, and then on the right-hand side having a positive charge. Now we don't need the charge to be 0, we just need it to be the same. So in this first reaction, it happens to be 0. In the second reaction, in this first reaction, your left-hand side is 0. Sorry, my dogs are barking outside and it's throwing me off. And on the right-hand side, if you add in 1 electron, now you also have a net charge of 0. So that one's done. The one where we added in water and hydrogen can be a little bit more tricky. And again, it has to do with the net charge. So if we look on the right-hand side, you have a net charge of positive 2, right? Positive 2 from the Mn, and water has no charge, so just positive 2 altogether. Then before you look at the electrons, if you look at the charges coming from your ions, here you have positive 8, here you have negative 1. And so to balance this out and making it equal to negative 2, we'll add in 5 electrons. So then if you look at our net, 5 electrons or 5 negatives plus 8 positive plus 1 negative, that gives you a net of positive 2 on each side, and that's what we'll need. So now your half reactions are balanced. So now you can balance the whole thing. And then the next few slides have talking about the multiplier. So if I go back to what I see here, if I want these electrons to be the same, right, because that's what redox is, an exchange of electrons, and those electrons have to be the same, then I would just have to multiply my first reaction by 5. Right? Because then I'd get 5 electrons from my first reaction, half reaction, and then 5 from my second. So that's what this part is talking about. And to do that, just what we talked about, this one gets multiplied by 5. We don't need to multiply by anything, so you can say by 1, but that one we don't need to do anything in this case. So once you have your electrons balanced, then you can add your reactions together. So on the left-hand side are all my reactants. So 5 silver from my first half reaction, 8 hydrogen positive, and just 1 MnO4 negative from my second half reaction. And then on my product side, from my first half reaction, I have my 5 silver. From my second half reaction, I have Mn2 positive and 4 water. You might notice here your electrons would cancel out, and if there was anything else that was identical, whether it was molecules or ions, on the left hand and the right hand side, you could also cancel those, but we don't have any in this case. So that is what we're doing to balance under acidic conditions. If you are following the Alberta curriculum and you are reading along in the textbook, you might find some information about basic conditions, but basic conditions are no longer in the curriculum. So when you're looking at the diploma, the only thing that would come up is acidic conditions, like this last example we just did. So if we were going to try another one, balancing a half reaction in acidic conditions, again, we take a look, just last one here, we would see you have 2 chromium on the left and only 1 on the right. So your first goal is balance anything other than hydrogen and oxygen, so I'll put a 2 there. And then your second step is to then add in waters to balance out the oxygen. So you have 7 oxygen on the left, so we would need 7 water molecules on the right hand side, because that would give us 7 oxygen. But what it also does is introduce hydrogen, and 7 times 2 is 14. So to balance out hydrogen, we'll add 14 hydrogen molecules on the reactant side. Then lastly, you balance out your charges. We need to add in electrons, and again, our goal is to get the charge on each side the same. So on our right-hand side, you have a net charge of +3. On the left-hand side, oh, I missed something. That is a 2 in front of that. So 2 times 3, you have a net charge of +6 on the right-hand side. On the left-hand side, you have 14 positive, 2 negative, so that's a net right now of +12. So if we want to have +6, you need to add in 6 electrons, right? So if we add 6 electrons to +6, 6 electrons to +12, that will leave you with a net of +6. So that would be your half reaction balancing with the steps of acidic conditions. So I hope that was helpful. We'll be moving on tomorrow, starting to look at oxidation numbers. And once we know those, we can start to balance in another way using oxidation numbers. Thanks for watching. Bye.